Hello everybody, this is Mr. Harrison, obviously. This video I'm doing today is for my Algebra 2 students. We're going to be doing lesson 52 in the book. I'm on page 220. This is chemical mixture problems. Now, I got to tell you, it seems like we've already done these. I teach this class every year, and then I teach it to multiple classes, so probably I've taught it to others and haven't taught it to you. It just seems like I have already. If I have, well, hey, you're getting it again. And we're not going to make a big deal about it. It's always good to review anyway. First thing I want to tell you is that they're going to be taking certain percentages of different mixtures and putting them together and finding out what the percent of the final result is. And right up here on the board, I have two equations that are crucial. I encourage you to write down these formulas on your paper every time you get one of these. The first one is amount percent plus amount percent equals amount percent. We're going to change it up here in a little bit, but I write that down every time I do these kinds of problems, and then underneath it I put the information that is given to me in the problem. The second one is that equation over to the far right. It says amount 1 plus amount 2 equals amount 3. That one's really kind of the key to solving these. And we're going to talk about this as we do these examples. I'll explain more. I'm looking at the very first example in the middle of page 220. It says a druggist has one solution that is 10% iodine and another that is 50% iodine. He has two different solutions that he's going to be putting together. And then it says how much of each should the druggist use to get 100 milliliters of a mixture that is 20% iodine. It's going to give you a lot of instruction, just a lot of talking on this one problem. There are 1, 2, 3, 4, 5, 6 pieces of information that they could give you. They could give you this first amount. They could give you this second amount, or they could give you the third amount, which is the final amount, what you're trying to end up with. They could give you the percent of the first amount. They could give you the percent of the second amount, or they could give you the percent of the final solution, again, what you want to end up with. And so there's 6 things that are missing there that they're going to give us, and we have to fill in where we can. In this one, they tell us the 2%. They tell us the percent of the very first solution, and they tell you that it's 10. Now I'm going to stop right there, and you notice I just put 10. I don't put 10%. I don't put 0.1, which is the decimal approximation, not approximation, which is the decimal form of 10%. I don't do it on the second one either. They tell me the second one is 50%. It's a 50% solution. I just put up the whole number 50 right there. And their question is, how much of each should the druggist use to get 100 milliliters? That's the amount that he wants. That is the final amount, or the third amount that we're trying to find. That is 20%. I'm going to go ahead and put that 20 right there. We do not know the first amount. We do not know the second amount. They haven't given it to us. We're going to put something in there to help us represent it. You can put A and B, X and Y. The book uses the letters P and D, standing for one of them was poured in, one of them was dumped in. It doesn't matter. I'm going to use X and Y. We're going to get to that second equation in a second, but in the meantime, I'm just going to go ahead and work this out. X times 10 gives me 10x. y times 50 gives me 50y. And 100 times 20 gives me 2,000. Let's do a line up here. Now we get to that crucial second equation where I said amount 1 plus amount 2 equals amount 3. This is always going to be the case, and you want to write that up. This amount, the x, plus the amount y, the second amount, will equal the third amount, 100. There are exceptions to this. Occasionally, it's x minus y. They are taking something out. I'll point that out when it shows up, but almost always it's amount 1 plus amount 2 equals amount 3. Every time. Now, this is not true for the percents. I cannot say that 10 plus 50 equals 20. I can't even say 10 plus 50 divided by 2 equals 20. We aren't focusing, we aren't fooling with the percents at all when it comes to that second equation. It's interesting if you notice this always happens. See how this is 10% and this is 50%? The final percent will always be between those two. Just throw that out there as a bit of information. But let's look at that second one again. It says amount 1 plus amount 2 equals amount 3. My first amount was x. My second amount was y. My third amount was given to me. It was 100. Now, excuse me. In this first problem, we had two unknowns. I've told you before, in order to to solve an equation, if you have two unknowns, you must have at least two equations. Well, they've given us two equations. 10x plus 50y equals 2,000. And now this second one over here, x plus y equals 100. We can do an elimination. We can do a substitution. We're going to do a substitution here in a moment to solve for this. So in this second one, I can solve for either x or y and substitute it in here and solve for the other. Which one do you solve for, x or y? Doesn't matter. Take your pick. I will tell you this, though. Notice that it's 10x, 50y. If you pick the variable that has the smaller coefficient, the lesser coefficient, then you won't have to deal with any negatives. So in other words, if I solve for x over there, I won't have to deal with negatives. I can solve for y if I want to, but because 50 is greater than 10 and 50 is with the y, I'll end up with negatives in my problem. They'll all work out in the end, but I won't have to fool with negatives. So let's solve for x over here in this equation. If I'm trying to get x by itself, I'm going to say minus y on both sides. So x equals 100 minus y. That is my key to solving this problem. So now I'm going to come over here. I'm going to substitute 10x. Instead of the letter x, I'm going to write 100 minus y. I write the rest of the problem down. 50y equals 2,000. Multiply this out, distributive property. 10 times 100 is 1,000. 10 times y, or in this case, negative y gives me minus 10y, plus 50y equals 2,000. There I've got an equation with only y's in it. I get my whole number parts together. I subtract 1,000 from both sides. Over here I have negative 10y plus 50y. That's 50y minus 10y. That'll give me 40y. And that equals 2,000 minus 1,000 is 1,000. We're going to divide both sides by 40. And I get that y is 25. there are 25 milliliters of the 50% solution. If there are 25 milliliters of the 50% solution, how much of the 10% solution is that? Well, that's easy. I just come over here. X equals 100 minus whatever Y was, in this case 25. X equals 75. Okay. In your homeworks, please label these. This was 25 of the 50% solution. And that's X is 75 of, my phone's of the 10% solution. Gonna pause. Well, I'm back. We just finished the first example. I've gone ahead and erased it. We're going to move on to the second example. I'm at the bottom of page 221. Now, we're already 11 minutes into this video. Sorry for making it so long. I'll try to be quick on the second one. If you look at the example, it says a chemist has one solution that is 10% salt and 90% water. They give you two different percents for the same amount. You've got to pick which one you want. Do you want to do it in terms of its salt content or its water content? You can do either one. It won't matter. But if you do the first amount in its salt content, every one of them has to be the percent of salt that it has. If you do it by its water content, every one must be the percent of water that it uses. Now, the second one, second amount, they only give you its percent salt, 2% salt. That means that it's 98% water. Again, excuse me, you could go through and do everything in terms of water or in terms of salt. Let's just keep it salt. So, and here it is again. It says he has a solution that is 10% salt. By the way, earlier I did not have parentheses around these percent signs. I hope you understood that it was amount 1 times its percent plus amount 2 times its percent equals amount 3, the final amount, times it percent. If I did not make that clear, I apologize, and there it is stressed now. So the 10 is the percent of the salt that it is. The second one says it's 2% salt. And the last one, they want 1,400 milliliters of 6% salt. We do not know the first amount. I'm going to use the letter X. I started to write amount there. It's a big old X now. And amount Y. Amount 2 is 1. As I said before, it's crucial that you write down amount 1 plus amount 2 equals amount 3. X plus Y equals the final amount, which is the 1,400, not times the 6, just that right there, 1,400. Now, as I said in the first example, we can solve for either X or Y, doesn't matter. If you solve for the Y, because this is 2Y, the Y has a 2, because it's 1. Since we solve, getting tongue-tied here. If you solve for Y, you won't have to deal with any negatives. So I have 10x plus 2y equals whatever 1,400 times 6. That's 6,000. That's 8,400. And over here, I'm going to solve for y. I'm not going to use a red pen here. Minus x, y equals 1,400 minus x. I'm going to come over here. 10x plus 2. And instead of the letter y, I'm going to write 1,400 minus x equals 8,400. 10x plus distributive property 2 times 1,400 gives me 2,800. 2 times negative x gives me minus 2x. 8,400. 10x minus 2x gives me 8x. I'll subtract 2,800 from both sides. What will that give me? 84 minus 28 is going to give me 56. 5,600. Make sure that's right. Carry the forward. Yes, there we go. Divide by 8. Divide by 8. 8 goes into 56, I believe, 7 times. My math is just a little off today. 700. That means you had 700 milliliters of the 10% solution. How much did you have of the 2% solution? Well, it turns out that it's also 700 if you subtract 1,400 minus 700. So there you go for that. Just one thing, last thing to point out. Occasionally they'll say how much water must be evaporated or something like that. And you have to deal, in a salt solution or some other solution like that. You may have to deal with 0% or 100% is the percent that is being taken off. Or like if you've got a salt solution, they say how much water must be evaporated to get a higher concentration of salt. Well, the water you're taking off is 0% salt. So that's something to consider. I'm sure that'll show up in a homework, and we'll address that further when we see it. Good luck. Give me a call. Text me. Hope you do well. Hope you're enjoying this time off and the nice weather finally. God bless you. Be blessable. That's what I haven't been saying. Be blessable.